This and the following videos, we will talk about inequality indices. So indices that measure income inequality. First of all, we have to recognize that measuring inequality is not an easy task. There is no one correct way of measuring inequality. Each measure will emphasize different aspects. And therefore, you should be aware that each inequality measure has its advantages and disadvantages. None of them can fully embrace the reality of people who have high and low income. But in order to be able to compare societies and the distribution of different groups in society and so on, it is important to measure inequality. Now, we will do this through two measures. One is the income variance, and one is the Gini coefficient. So we will start with the variance, which you have learned in your statistics course, which tells us the average dispersion of a distribution around, or the dispersion of a distribution around the mean. So the formula you can see up here, and if you remember from your statistics course, you have here the household income, and here on the vertical axis you have the density of household incomes. So what is the share of overall incomes that fall into this one income bracket? And we typically have a curve that looks something like this. Okay, and so then you have on this curve, you have the mean. So the mean is the average income, and the variance tells us what is a measure for the dispersion. So basically for how wide that distribution is, how far away any particular point on average lies from the mean. Okay? So what you do is basically for every household, you subtract that household's income from the mean income and take the square of this. Why? Well, because we want to give the incomes that are greater than the mean and those that are smaller than the mean, but at equal distance, we want to give them the same weight here. Because if we didn't do that square, then you can try this at home, but we would be left with simply a variance of 0. Then what you see very often is the so-called standard deviation, which is just the square root of the variance, which tells us by how far on average incomes deviate from the. Okay, so you have here lots of incomes. If I just in this distribution just give you that red zone here, so you have lots of incomes that are in that red zone that don't deviate a lot from the mean. And then if we assume this distribution is symmetric, let's say the green zone is somewhere out here, you have very few that deviate a lot. And the standard deviation tells us to what extent what is the average deviation from the mean. So if you have a variance that looks like this, that is a very, very flat curve with a mean here, that obviously has a very high variance. Whereas if you have a distribution that looks more like this, where most values are very close to the mean, that has a very low variance and hence also a low standard deviation. The big problem with variance as a measure for income inequality is, but I see two problems. One is that we don't have a feeling for it. It's not that the variance is bounded between any two values. So if I tell you the income variance in the US is 3 million or 3 billion, we wouldn't have a feeling for it. we can get a feel for it with the standard deviation. When we say, okay, the average income in the US deviates from the mean by $10,000, we do have a feel for that. But even then, the variance is sensitive to transfers, which means that if we take something away from one household and give it to another, that would actually change the variance. And that can, in some cases, make sense. But in other cases, it's just not very useful for measuring changes in income inequality. So therefore, the income variance is not something that is sometimes used, and is sometimes used for good reason. But you have to be aware that even though as a statistical measure we often use it, it's not as useful as other measures. Now, what we need to think about when using, or when we're even taking a step back and when we're constructing an index for inequality, we need to make sure that it fulfills the purpose that it's actually designed for. And there is one principle that Du counted previously and Dalton have come up with, that is very useful. So when an index fulfills the Pigou-Dalton principle, that's kind of a minimum requirement for an index to be for an inequality. What does it say? So first of all, so the Pigou-Dalton principle tells us what happens to an index if we redistribute income. Because most of the time when we use an inequality index, it's about measuring inequality before and after a policy change, right? So a government changes its redistribution policy, it taxes some people, gives transfers to others. We want to know to what extent that changes the inequality. And so the Pigou-Dalton, because even if, let's say, if this policy changes incomes, but that is not reflected in the inequality index, that's problematic. And so the Pigou-Dalton principle tells us that if we give a transfer from a richer household to a poorer household, and that transfer preserves the ranking of that household, the inequality index must decrease. Okay, so the important bits of information are actually here. So we need a transfer from a rich to poor household that still preserves that ranking. So what does that mean? It means that even after the transfer, the rich household is still richer than the poor one. And if we get that, then if we have such an index and it decreases following that transfer, then the Pigou-Dalton principle is fulfilled. Now, obviously, that incorporates a normative judgment by saying that, okay, having a lower income distribution is a good thing. But obviously, this depends on where you stand politically and so on. But most people would agree that there's per se nothing wrong with that state. Now, let's look at the Pigou-Dalton principle in practice. So what we want to look at here is we want to look at a transfer of X from a richer household to a poorer household. So remember, the formula for the variance is 1 over n times the sum of the mean minus the income of a particular household squared. Okay? And so here what we've done, we've just taken this apart. So instead of having the summation that you can see up here, we have now just single terms here that we sum up. And what we do in addition, we take one of the richer households and take away X from that household and give it to a poorer household. And what we want to know now is whether the variance decreases through that, which it should if it was to fulfill the Pigou-Dalton principle. Now, how do we arrive at that derivative? Well, we have to take the derivative of that long expression with respect to x, which is which looks more daunting than it actually is. Okay? So we can actually apply the summation and the chain rule when it comes to the derivatives. So what we have here is let's start with this term here, and not forget that also we have 1 over n. Okay, so we have the first derivative of all that is 1 over n times, and then we have a square here that we need to care about, times 2 times whatever is in the parentheses here, minus ya minus x, and because we have minus x here, we have to apply the chain rule and multiply this by -1. And then we have to also do the first derivative of this expression here again, remembering that it's pre-multiplied by 1 over n. So we have 1 over n times 2 for the square times whatever is here in brackets, and it's actually plus x, so we don't need to do anything more with that. So the chain rule doesn't really apply here. Now, if we simplify that, what you will see comes out of it is that the two means will cancel out, because we have here on the left here we have -1 times the mean, and in the term on the right we have +1 times the mean. So if we add the two of them up, they cancel out. So all we're left with then is 2 over n, apologies, 2 over n times ya plus x, and then in the term on the right we have plus x, sorry, plus x minus yb, which we can further simplify to 2 over n times ya minus plus 2x minus yb. And that's how we arrive at that derivative here at the bottom. So that's what we've shown now. Now, what we need to assume here for the Pigou-Dalton principle to actually work is that the ranking of those two households is preserved. So the transfer is not that big that it would all of a sudden turn the rich household into the poor household and vice versa. So that the income ranking is preserved. And so if that's the case, what we also know is then that that first derivative and that expression here in parentheses is less than 0. Okay, so all you need to do here is you need to take that x and add it over here, and you arrive immediately at that condition. So under the condition that the transfer is so small that it doesn't change the ranking, the transfer actually reduces the variance. And that means the variance fulfills the Pigou-Dalton principle. So, there is reasons why we don't often use the variance, but this was just one example of saying we take a measure of inequality and we see if it fulfills this very important principle. And so that it actually, that's the necessary, but maybe not the sufficient condition for it being a useful index of inequality. The big problem with variance is it depends on the currency, on the units, and so it's very hard to actually compare variances over time, and you know, the deflation becomes very difficult. So that's why a lot of people don't